Welcome to Future Forward, where we explore the tech that's shaping tomorrow. Imagine a world where your smartwatch charges itself from your body heat, your clothes power, your headphones, and industrial machines quietly recycle their own wasted warmth into electricity. Sounds like science fiction, right? Well, it's getting closer to reality thanks to an incredible innovation, flexible thermoelectric semiconductors. For a while now, we've known how to turn heat into electricity using thermoelectric materials. But there was a big snag. Most of these materials were stiff, rigid, and brittle. Think about trying to wrap an old ceramic tile around your wrist. Not exactly comfortable or practical for smartwatches or clothing, is it? This inflexibility seriously limited where these amazing heat-converting materials could be used. But scientists are a clever bunch, and they've been cooking up some fascinating new recipes for these materials. Picture this: ultra-thin bismuth telluride fibers. These aren't your grandma's knitting yarn. These are high-tech fibers that can bend and flex repeatedly without losing their power-generating magic. This breakthrough means smart clothing that actually generates electricity from your body. Heat is now a very real possibility. Then there's something called vacancy engineering. It sounds complex, but essentially, scientists are carefully tweaking the atomic structure of certain metal alloys, creating tiny empty spaces. These controlled imperfections significantly boost the material's ability to convert heat into electricity and, crucially, also make them wonderfully flexible. And the best part? These advanced materials can often be made using simple, cost-effective methods, which is key for bringing them to the mass market. Silver-based compounds, especially one called silver selenide, are also stepping into the limelight. They're naturally quite bendy and perform exceptionally well near room temperature, perfect for those wearable devices we've been dreaming about. And it's not just about metals. Researchers are also making huge strides with flexible plastics or polymers. By mixing these polymers with tiny nanomaterials like carbon nanotubes, they're creating lightweight, efficient heat harvesters that are showing real promise for medical monitoring and even therapeutic applications. So we have these incredible new materials, but how do we actually turn them into usable devices? This is where cutting-edge manufacturing techniques come into play. Imagine printing electronics just like you print a document. Advanced methods like inkjet and screen printing are allowing us to create flexible thermoelectric circuits on all sorts of surfaces, including fabrics. Some scientists are even using liquid metal, like a special gallium-indium mix, for the electrical connections. This makes the devices even more bendable and durable than those using traditional silver paste. And 3D printing is also joining the party, helping to create thermoelectric devices that are not only highly stretchable, but, in some cases, can even heal themselves if damaged. The potential applications are truly exciting. In the world of wearables, think self-powered fitness trackers that never need plugging in, medical sensors that continuously monitor your health without the hassle of batteries, and even smart clothes that can intelligently regulate your temperature, all powered by the heat from your own body. Beyond our bodies, these flexible materials can be wrapped around hot pipes in factories or contoured to fit complex machinery, capturing waste heat and converting it back into useful energy. This represents a huge step forward for energy efficiency and sustainability on an industrial scale. Now, it's not all smooth sailing just yet. There are still challenges to address. Scientists are working hard to make these materials even more efficient at converting heat to electricity across a range of temperatures. They also need to ensure these devices can last a long time, especially with constant bending and flexing, and of course, figure out how to manufacture them affordably on a large scale. For anything that touches our skin or potentially goes inside our bodies, being non-toxic and biocompatible is absolutely critical, and that's a major focus too. But despite these hurdles, the future for flexible thermoelectric semiconductors is incredibly bright. With ongoing research into new materials, smarter device designs, and more advanced manufacturing techniques, we are on the cusp of a new era. It's an era where the environment around us, and even our own bodies, can contribute to powering the technology that enhances our lives. Imagine the silent, invisible energy working for us, everywhere. It's a subtle revolution, but one that could fundamentally change how we interact with energy and technology forever. Thanks for tuning into Future Forward. Join us next time as we delve into another electrifying innovation.